Infrastructure investment plans, $1.8 billion allocation for renewable energy projects and their implementation timeline by 2025. Introduction. The recent announcement of a $1.8 billion allocation for renewable energy projects marks a pivotal moment in the global transition towards sustainable energy. With a clear implementation timeline extending through 2025, this investment is set to foster innovation, create jobs, and stimulate economic growth across various sectors. This report synthesizes key insights from industry leaders and stakeholders, outlining the significance of this funding, the specific projects involved, and the collaborative efforts required for successful execution. Overview of the $1.8 billion investment. The commitment to allocate $1.8 billion toward renewable energy infrastructure reflects a strategic move by both government and private sectors to enhance the nation's energy landscape. As global climate initiatives gain momentum, this funding is designed to facilitate the development and implementation of clean energy technologies, specifically focusing on hydrogen and ammonia production. Key highlights. 1. Government initiatives. Entrepreneur Sunil Kanoria emphasizes the importance of government support in driving infrastructure funding. He notes that such proactive measures are crucial for fostering innovation and economic growth, highlighting a broader recognition of the government's role in catalyzing infrastructure improvements and renewable energy investments. 2. Specific projects. Linde, a prominent industrial gas company, plans to utilize part of this investment to supply clean hydrogen for OCI's large-scale blue ammonia project in the U.S. Gulf Coast. This initiative showcases the potential of hydrogen as a clean energy source and its integration into broader renewable energy strategies. 3. Collaborative efforts. The initiative encourages collaboration among various stakeholders, including businesses, government entities, and research institutions. This collaborative framework is vital for addressing the complexities involved in energy transition and infrastructure development. Implementation timeline. The implementation of the $1.8 billion investment is strategically phased over 3 years, with significant milestones planned along the way. 2023, the announcement of the funding allocation marks the beginning of initial project planning phases. Companies like Linde are poised to leverage this investment for clean hydrogen projects, setting the groundwork for future developments. 2024, development of infrastructure will commence, focusing on constructing facilities necessary for the production and distribution of renewable energy sources, particularly hydrogen and ammonia projects. This year will see increased activity as stakeholders mobilize resources and expertise to advance project goals. 2025, key renewable energy projects are expected to reach completion, with operational facilities ready to contribute to the energy grid. This timeline signifies a rapid progression from planning to execution, underscoring the urgency of transitioning to sustainable energy practices. Common themes. Across various sources, several common themes emerge regarding the investment in renewable energy projects. Innovation and collaboration. All sources emphasize the critical role of innovation and collaboration in driving infrastructure investment. By pooling resources and expertise, stakeholders can effectively address the challenges posed by energy transition. Economic benefits. There is a shared optimism regarding the economic benefits of renewable energy projects. These initiatives are expected to create jobs, stimulate technological advancements, and ultimately contribute to a more robust economy. Differences in focus. While there is consensus on the importance of the investment, differences in focus among stakeholders are evident. Government versus private sector. Kanoria's perspective highlights the importance of government initiatives, suggesting that public support is essential for fostering growth. Conversely, Linde's focus illustrates the private sector's role in implementing specific projects, thus showcasing the synergy between public funding and private innovation. Broader implications versus specific applications. Kanoria discusses the broader implications of infrastructure investment for economic growth and innovation, while Linde provides a detailed account of a specific project that exemplifies the application of this investment in the renewable energy sector. Conclusion: the $1.8 billion investment in renewable energy projects represents a concerted effort to enhance infrastructure and respond to the urgent need for sustainable energy solutions. The integration of government support and private sector innovation is expected to lead to substantial advancements by 2025, establishing a strong foundation for future growth and energy sustainability. As stakeholders collaborate to implement these initiatives, the ripple effects of this investment will likely extend beyond the energy sector, fostering broader economic and environmental benefits for society as a whole. The commitment to renewable energy not only addresses immediate energy needs but also positions the nation as a leader in the global effort toward a sustainable future. By harnessing the power of clean energy technologies and fostering innovation, this initiative sets the stage for a greener, more prosperous tomorrow. The $1.8 billion allocation for renewable energy projects is a significant investment designed to reshape infrastructure and advance clean energy initiatives. However, within this optimistic narrative, several counterintuitive elements emerge. 1. Rapid implementation versus complex challenges. While the implementation timeline suggests a swift progression from planning to execution, the reality of infrastructure projects often involves unexpected delays and complexities. The assumption that projects can be completed by 2025 may overlook regulatory hurdles, technological challenges, and community resistance that could impede progress. The juxtaposition of an ambitious timeline against the historically protracted nature of such projects presents a counterintuitive scenario. 2. Government versus private sector roles. Sunil Kanoria emphasizes the government's critical role in infrastructure funding, which suggests a reliance on public initiatives to drive innovation and economic growth. In contrast, Linde's focus on private sector involvement highlights a significant shift where the private sector is expected to take a leading role in implementing renewable energy projects. This divergence raises questions about the actual effectiveness of government funding if private entities are tasked with execution, potentially leading to mismatched expectations regarding accountability and outcomes. 3. Hydrogen as a clean energy source. Linde's commitment to supplying clean hydrogen for OCI's blue ammonia project may seem like a breakthrough in renewable energy. However, the production of hydrogen, particularly through methods such as steam methane reforming SMR with carbon capture, can be energy intensive and may not be as clean as portrayed. This presents a counterintuitive situation where the touted benefits of hydrogen as a renewable resource could be undermined by the environmental impacts of its production process, challenging the narrative that hydrogen is inherently a green alternative. 4. Optimistic job creation. The expectation of job creation stemming from these renewable energy projects is a common theme. However, the reality is that while infrastructure investments often promise job growth, the nature of these jobs may not align with the skills of the local workforce. Furthermore, automation and technological advancements might limit the number of jobs created, contradicting the assumption that these investments will uniformly benefit employment rates. 5. Collaboration versus competition. The initiative promotes collaboration among various stakeholders. However, the competitive nature of the energy sector might lead to conflicts of interest. Companies may prioritize their proprietary advancements over collaborative efforts, undermining the intended synergy and potentially resulting in fragmented progress toward renewable energy goals. This discrepancy between the ideal of collaboration and the competitive environment presents a counterintuitive challenge. 6. Economic growth versus environmental impact. The projected economic benefits of the $1.8 billion investment are tied to job creation and technological advancements. However, the push for rapid infrastructure development could lead to adverse environmental impacts, contradicting the primary goal of transitioning to sustainable energy. This raises questions about whether the short-term economic gains justify potential long-term environmental costs, highlighting a tension between immediate economic interests and broader ecological responsibilities. 7. Global versus local perspectives. The narrative emphasizes a global commitment to renewable energy. Yet the local implications of these large-scale projects may not align with global goals. Communities affected by infrastructure developments may experience disruptions or adverse effects, leading to resistance against projects that are framed as universally beneficial. This disconnect between global aspirations and local realities presents a counterintuitive conflict where the pursuit of global sustainability could exacerbate local challenges. In summary, while the $1.8 billion allocation for renewable energy projects embodies a forward-thinking approach to infrastructure investment, it is essential to recognize the counterintuitive complexities that accompany such initiatives. The interplay between optimistic projections and the realities of implementation, stakeholder dynamics, and environmental considerations underscores the multifaceted nature of transitioning to sustainable energy solutions. In the report concerning the $1.8 billion allocation for renewable energy projects, several critical aspects may be overlooked by the general audience, which are crucial for understanding the broader implications of this investment. Below are the important content elements and their significance. 1. Government's role in infrastructure investment. While many reports highlight the financial commitment of $1.8 billion, the significance of government involvement in fostering innovation and infrastructure development often gets underplayed. Sunil Kanoria's insights emphasize the proactive role of the government, which is crucial for stimulating both economic growth and technological advancements. This collaboration between public and private sectors can lead to a robust framework for sustainable energy transitions. Significance. Understanding the government's role is vital because it sets the stage for public policy and funding that can be leveraged to attract further investments from private entities. The government's involvement can also lead to regulatory frameworks that facilitate the deployment of renewable technologies. 2. Specific projects and their implications. The mention of Linde's Clean Hydrogen Initiative for OCI's blue ammonia project is significant. This project is not just another renewable energy endeavor, it represents a broader trend towards hydrogen as a clean energy source which is gaining traction in the energy sector. By focusing on a specific project, stakeholders can gauge the practical application of the allocated funds and see a tangible outcome. Significance. The potential for hydrogen as a clean fuel is immense as it can reduce carbon emissions significantly. This focus on hydrogen projects signifies a shift in energy strategies that could affect various industries including transportation and manufacturing, making it a key area to watch. 3. The importance of collaboration. The report emphasizes collaboration among various stakeholders including businesses, government entities, and research institutions. This collaborative approach is essential for navigating the complexities of energy transition. However, the report does not detail how these collaborations will be structured or the potential challenges they might face. Significance. Partnerships are crucial for sharing expertise, resources, and technology, which can lead to more innovative solutions and accelerate the implementation of renewable energy projects. Understanding the dynamics of these collaborations can provide insights into the potential success or pitfalls of the overall initiative. 4. Implementation timeline and urgency. The timeline for implementation, stretching from 2023 to 2025, indicates an aggressive push towards renewable energy deployment. This urgency reflects the increasing global need for sustainable energy solutions in the face of climate change. Significance. The rapid timeline signals to investors, companies, and stakeholders that there is an immediate need for action. It sets expectations for progress and accountability, which can influence future investments and project planning in the renewable energy sector. 5. Economic benefits and job creation. While there is optimism surrounding job creation and economic benefits stemming from these projects, the report does not quantify these benefits or specify which sectors might see the most significant impacts. Significance. Quantifying job creation and economic impacts can help in garnering public support and further investments. Understanding where these jobs will be created, e.g., manufacturing, installation, maintenance, can guide workforce development initiatives and educational programs aimed at preparing individuals for new roles in the renewable energy sector. 6. Potential for innovation. The report emphasizes innovation as a central theme. However, it does not delve into the specific technologies or methodologies that might emerge from this investment. Highlighting potential innovations could provide a clearer picture of the investment's long-term impact. Significance. Innovation in renewable energy technologies like energy storage, smart grids, and carbon capture can radically change how energy is produced and consumed. Stakeholders should be aware of these possibilities to understand the transformative potential of the $1.8 billion investment. Conclusion. In summary, the $1.8 billion allocation for renewable energy projects presents a multifaceted opportunity that extends beyond mere financial commitments. The interplay of government involvement, specific project details, collaborative efforts, a tight implementation timeline, economic ramifications, and the potential for innovation are all significant elements that warrant close attention. Recognizing these factors can lead to a more comprehensive understanding of the implications of this investment and its role in shaping the future of renewable energy infrastructure. The allocation of $1.8 billion for renewable energy projects reflects a pivotal moment in infrastructure investment aimed at promoting sustainable energy solutions. Here are the 4 most valuable points for in-depth analysis and discussion. 1. Government commitment to renewable energy. The proactive role of government in infrastructure funding is crucial. As highlighted by entrepreneur Sunil Kanoria, government initiatives are not only vital for catalyzing investment but also for fostering an innovative environment that can lead to substantial economic growth. The government's commitment signifies a shift in policy focus toward renewable energy, which is essential for meeting global sustainability goals. This commitment can be analyzed in terms of its potential impact on job creation, economic stimulation, and the reduction of carbon emissions. Furthermore, examining how government policies can attract private investment, facilitate research and development, and create regulatory frameworks that support renewable energy initiatives would be beneficial. 2. Specific projects and technological innovations. The involvement of Linde in supplying clean hydrogen for OCI's blue ammonia project illustrates the practical application of the allocated funds. This project highlights the growing importance of hydrogen as a clean energy source and its integration into broader renewable energy strategies. An in-depth analysis could explore the technological advancements in hydrogen production and distribution, the scalability of such projects, and their feasibility in the current energy landscape. Additionally, discussions could include the environmental implications of hydrogen production, including the shift from fossil fuels to cleaner methods and the potential for hydrogen to support energy storage and grid stability. 3. Collaborative frameworks for success. The initiative promotes collaboration among various stakeholders, including businesses, government entities, and research institutions. This collaborative approach is essential for navigating the complexities of energy transition and infrastructure development. A deeper discussion could focus on the mechanisms of collaboration, how different sectors can work together effectively, share resources, and innovate collectively. Analyzing existing models of successful public-private partnerships in renewable energy can provide insights into best practices and strategies for overcoming challenges in implementation. Furthermore, understanding the role of research institutions in driving innovation and providing technical expertise can enhance the effectiveness of these collaborations. 4. Implementation timeline and urgency for action. The outlined timeline for project development, from announcement in 2023 to expected completion by 2025, indicates a sense of urgency in transitioning to sustainable energy practices. This rapid progression emphasizes the need for effective project management and timely execution. An analysis could delve into the potential barriers to meeting this timeline, such as regulatory hurdles, supply chain issues, and the availability of skilled labor. Additionally, discussing the implications of timely project completion on the energy market, job creation, and technological advancement can provide a comprehensive understanding of the investment's potential impact. The urgency also raises questions about how quickly the industry can adapt to new technologies and the importance of maintaining momentum and policy support to sustain these initiatives beyond 2025. In conclusion, the $1.8 billion investment in renewable energy projects can significantly influence the future of energy infrastructure. Analyzing the government's role, specific technological innovations, collaborative efforts, and the urgency of implementation can provide deeper insights into the potential for these projects to drive sustainable growth and innovation. 1. The Tennessee Valley Authority TVA and the New Deal 1933 to 1939. The TVA was established as part of President Franklin D. Roosevelt's New Deal during the Great Depression. It aimed to provide navigation, flood control, electricity generation, and economic development in the Tennessee Valley, a region particularly affected by the economic downturn. With significant federal investment, the TVA constructed dams and hydroelectric plants, transforming the energy landscape while promoting economic development, job creation, and modern infrastructure. 2. The Interstate Highway System 1956. Initiated by the Federal Aid Highway Act of 1956, the Interstate Highway System is one of the most extensive public works projects in U.S. history. It was designed to create a nationwide network of highways that would facilitate interstate commerce, military transport, and improve road safety. The project involved massive federal investment and collaboration with state governments, leading to the construction of over 47,000 miles of highways and significantly impacting the American economy and the way people traveled. 3. The Marshall Plan 1948 to 1952, officially known as the European Recovery Program. The Marshall Plan was an American initiative to aid Western Europe after World War II. The U.S. provided over $13 billion, approximately $150 billion today, in economic assistance to help rebuild European economies. This investment focused on infrastructure, industrial recovery, and promoting political stability, which ultimately played a crucial role in the continent's recovery and integration, leading to lasting economic growth and cooperation in Europe. The $1.8 billion allocation for renewable energy projects marks a pivotal step in the global transition to sustainable energy. This investment is not only a financial commitment but also a strategic initiative aimed at reshaping infrastructure to support clean energy solutions. The anticipated outcomes and developments leading up to 2025 can be categorized into several key areas. Predictions for future developments. 1. Increased renewable energy capacity. By 2025, the investment is expected to significantly boost renewable energy capacity, particularly in hydrogen and ammonia production. The partnership between Linde and OCI for the Blue Ammonia project in the U.S. Gulf Coast exemplifies how targeted investments can catalyze large-scale clean energy production. This could lead to a nationwide increase in the availability of clean hydrogen, making it a viable alternative for various industrial applications. 2. Job creation and economic growth. The implementation of these renewable energy projects is projected to create thousands of jobs across manufacturing, construction, and technology sectors. This influx of job opportunities will likely spur local economies and contribute to the overall growth trajectory of the clean energy sector. As infrastructure projects ramp up, there will be a corresponding demand for skilled labor, further emphasizing the need for training programs in renewable energy technologies. 3. Innovative technological advancements. The funding will encourage research and development in clean energy technologies. Companies involved will likely focus on innovations to enhance the efficiency of hydrogen production and storage, as well as the development of new renewable energy technologies. This could result in breakthroughs that lower costs and increase the scalability of renewable energy solutions, making them more accessible to a broader range of industries. 4. Strengthened public-private partnerships. The collaborative nature of this initiative will set a precedent for future public-private partnerships in infrastructure projects. As stakeholders from government, industry, and academia work together, we can expect to see more integrated approaches to energy transition challenges. This collaboration will not only streamline project implementation but also create a robust ecosystem for sharing knowledge and resources. 5. Regulatory and policy evolution. As renewable energy projects gain traction, regulatory frameworks are likely to evolve to accommodate new technologies and practices. Governments may introduce more favorable policies to incentivize renewable energy adoption and streamline permitting processes for infrastructure projects. This regulatory evolution will be crucial for maintaining momentum in the transition to sustainable energy. 6. Global competitiveness in renewable energy. The U.S. is poised to enhance its position as a leader in renewable energy technology and production. By investing heavily in projects that focus on hydrogen and ammonia, the country could set benchmarks for emissions reductions while promoting energy independence. This competitive edge will not only benefit domestic markets but also position the U.S. as a key player in the global renewable energy landscape. 7. Public awareness and support for renewable energy. As the impact of these projects becomes more visible, public awareness and support for renewable energy initiatives are expected to grow. Successful implementation and visible benefits, such as job creation and cleaner air, may lead to increased public backing for further investments in sustainable technologies. This shift in public sentiment can drive politicians and policymakers to prioritize renewable energy in their agendas. 8. Challenges and resilience. Despite the optimistic outlook, challenges such as supply chain disruptions, technological hurdles, and fluctuating market conditions may arise. However, the resilience of the renewable energy sector, bolstered by substantial investment and innovation, is likely to navigate these challenges effectively. The lessons learned from initial project implementations can inform future strategies and adaptations. Conclusion. The projected outcomes from the $1.8 billion investment in renewable energy projects signal a transformative period for infrastructure and energy systems leading up to 2025. By fostering innovation, creating jobs, and emphasizing collaboration, this initiative has the potential to not only meet immediate energy needs but also lay the groundwork for a sustainable energy future. The integration of public and private efforts will be crucial in achieving these goals, ensuring that the transition to renewable energy is both effective and equitable. Overall, the future of renewable energy investments looks promising, with a strong likelihood of achieving significant milestones by 2025.